Hi, welcome back to this class. It's about Transformer Decoder, part 7, and I'll go through the whole part 7 in detail. So this is part 7 if I take the pointer or indicator here. So we're talking about this one. We already explained all these processes um, starting from here all the way from embedding uh, till here. We've done it. And also we've done the encoder that comes a K and value, a K and V matrices. They will form cross attention using Q from the decoder. So we've done this one. If you go back to earlier version, all these explained in detail, video by video, part by part. And now in part 7, we talk about this part, add and norm. Okay. So that is the add and norm. Recap what we had. We will have the results of feed-forward neural network, this one, and we have original input before feeding into this layer. So we have result of this one, feed forward, that result here. And we have also this one, this line. So if I just make it clear to you. So we have two lines so far. I just try to make it clear. What we are going to do, just take the blue color. So we have this line. We have this line. That's original X. And we have this line. That is feed forward X, feed forward neural network X plus the X. So we're keeping the original input, and we add it to the output from the feed forward network. So let's do that. So that's the feed forward, the output of feed forward network. And this is the original input. Element-wise addition, 0 plus minus 0.11, 0.585 plus 1.17, and 0 plus minus 0.86, and so on and so forth. It's element-wise. So we for the token 1, S start, and for the token 2, Ana, Arabic word that means I, and for token 3, Ahab. Token 3 means in English like. So we had I like Rojava. So Ana Ahab Rojava. So that's the translation for the Arabic word for English, I like Rojava. So here the matrix is found, residual, adding residual. That's the result from element-wise X plus feed-forward neural network X. To do normalization, we will take each value of this. We sum them up row-wise. So minus 1.11 plus 1.755 plus minus 0.86 plus 1.2. And then we divide it by 4 because there are 4 features. Likewise, we do the same for second row, token 2, and token 3 as well. Each one of them divided by 2. And then we get the mu. Once we get the mu, each value will xi minus mu, and we will square it to get the deviation. That's how it is done. Here the deviation is done, and squares of the deviation get the sum divided by 2. We will get and then divided by 2, and then we get the standard deviation, making square root for that value. Now, normalize will be the standard deviation, the deviation over standard deviation. Okay, the deviation square over standard deviation. Now, here is the results for the second token, and earlier we had the first token. Okay, that's how we found standard deviation, and standard deviation, uh, that's how we found it from the variance. So from the variance, we will square root of that one. It goes to 1.25. So then we have the result. Now this deviation divided by 1.25, you will have the first cell for the first row. Same thing, this deviation divided by 1.25, you will have the second result, and so on and so forth. So that's normalization kind of for token tree as well, same thing. We will get mean, and we will get deviation, which is the every single feature divided by the mean, minus mean, square it. So xi minus mean, and this would be squared over standard deviation. Okay, so that's the results here and here and here and there as well. So that's the results. Now, that's the final result after feed-forward, residual, and layer normalization. We have this array, token 1 start, and token 2 Anna, and token 3 Ahab. So this 3 by 4 dimension. Now, for what does it mean? That's the results that we have. Okay, that's the results that we have. So the the output from the residual add and layer norm, that is the result for it. What does it mean? It means that we already did residual for it, and we already did normalization, and before that we did the self-attention, previous tokens, okay, and we did cross attention. What does mean cross attention? It means that we did decoder encoder attention contextually. So we got the decoder, which is represented by keys and values, matrix K and matrix V, multiplied by matrix query, and the query comes from decoder. So query comes from decoder, decoder, and K and V came from encoder. So that's what we call it cross attention. This is done. And now the output is ready to be translated to final Arabic token. So the sentence that we took it at the beginning, I like Rojava, we're going to do another two process. First, linear projection, and then softmax, and then predicting the tokens. Stay tuned for the next. So this is done already. Now we have linear and softmax and the prediction finally. So if you have any question, these are the links that I have. So stay tuned for the next class. Thank you very much. Bye.